Hi everyone, welcome back. We will continue to learn this section, and here we will learn what is a P-series and what is a harmonic series. Okay, P-series, if the P is a positive constant, if the series of 1 over n to the p's power from n equals 1 to infinity, we call this series, this type of series is a P-series. If P equals 1, if P equals 1, so the P series turns to be 1 over n, the summation of a 1 over n as n equals 1 to infinity, equals 1 plus 1/2 plus 1/3 plus 1/4. And we call this specific P series as the harmonic series. How do we determine whether a P series converges or diverges? Here's the theorem. If a P is greater than 1, we call this P series converges. If the P greater than 0, less or equal to 1, then the P series diverges. So we can prove this theorem. It's simple. You can use the integral test. First of all, this P series satisfies the conditions of the integral test. Then apply the integral test, compare the series with the improper integral. Then use the knowledge we learned in 8.8. How do you determine an improper integral converges or diverges? Then to make the decision if the P series converges or diverges. Okay, so here's an example. We use this theorem to determine whether a P series converges or diverges. This series 1 plus 1 over cube root of 4 plus 1 over cube root of 9 plus 1 over cube root of 16, and so on. So first of all, we want to write this series as a P series, which means you need to find how much is the P, right? How much is the P? So let's see. Rewrite this series as a solution, as a summation. Okay, observe this each term. What's the pattern of this each term? Write a summation of, see here, the first term is 1, the second term is 1 over cube root of the 4. 4 is 2 to the second power, right? And 9 is 3 to the second power. 16 is 4 to the second power. So 2 is the second term. 3 is the third term. 4 is the fourth term. And here the 5 to the second is the fifth term. So therefore, the pattern. So the nth term, we can write nth term is 1 over cube root of n to the second power. That's the nth term. N is 1 to infinity. And then continue, we can write as a 1 over raise n to the 2/3 power. Okay, write this radical as an exponent form, rational exponents. So the exponent P is 2 over 3. So now P is 2 over 3, which is less than 1. Okay, so diverges. Diverges. Okay, so now I want you to click pause here to practice this example. Very similar. So the difficult part is that you need to find a P. How much is a P, right? And basically you need to rewrite this summation as a P series. Okay. Check the answer. Let's do it together. So 3 is the first term. The second term is 3 over 2 to the 5 over 3rd. 5/3 power. The third term is 3 divided by 3 to the 5 to the 3 plus, okay, we can write a summation as n is 1 to infinity. So the first term is 3 over 1. So the 3 over n to the 5 over 3 third power. Double check. When n equals 1, so denominator 1, so first term is 3. When n equals 2, so the denominator 2 to the 5 third power is correct. The third term is the denominator 3 to the 5 third power. The fourth term is 4 to the 5 third power, right? Okay, so now how much is P? P equals 5 over 3, which is greater than 1. Okay, so therefore, this series converges. Okay, you can copy this 3 plus 3, 2 to the 5 over 3, or we just write a summation, it's easier. Summation of 3 over n to the 5 over 3 as equals 1 to infinite converges. Okay,